Welcome to the SEI podcast series, a production of Carnegie Mellon University's Software Engineering Institute. The SEI is a federally funded research and development center sponsored by the U.S. Department of Defense. Today's podcast is available on the SEI website at www.sei.cmu.edu/podcasts. My name is Suzanne Miller. I'm a principal researcher here at the SEI, and today I'm very pleased to introduce colleagues Lori Flynn and Zach Kurtz, who work in our CERT division. And so before we get started with the topic of today's interview, tell me a little bit about how did you end up here and working on what you're working on? What is it about the SEI that drew you to this kind of work?
Let's see, so I have worked on code analysis in the past, and probably the most notable thing that I did was co-invent a method for polymorphic program detection. And the secure coding group here at SEI does a lot of work with static analysis, and so I'm excited to continue and expand on the previous kind of work that I did.
Okay, and Zach, what brought you here?
Well, before the SEI, I had a meandering career in various things that were quantitative, and I eventually ended up calling myself a data scientist, and came here as a general purpose data scientist with no background in cybersecurity, but I've been learning a lot.
There's a lot to learn in cybersecurity and a lot of data, so that sounds like a good match. So today we're here to talk about a new tool that is on its way on static analysis and a classification scheme, that's where the data part comes in, related to that. So why don't you tell us about this project and why is this project involved in the cybersecurity realm instead of just the normal sort of static analysis, code quality things that we normally do?
Yeah, so for the last 2.5 years or so, I've been leading related projects that are attempting to develop classifiers for static analysis alerts where we're trying to accurately predict whether an alert is true or false, to try to save time.
Sure.
Usually determining if an alert is true or false is a time-consuming process. There are a lot of alerts that come out of static analysis tools and limited money from organizations to pay for effort for people to analyze if they're true or false. So if we can improve automation of handling static analysis alerts, we can help to secure code by fixing real flaws.
So I know from my own background, that was one of the adoption barriers to using static analysis tools, is that you got lots of false positives, and filtering through what's the real problem and what are things that really can be ignored in whatever case we're working in. That, even when you're not talking about security, if you're just talking about code quality kinds of analysis, you still have that issue. So this could be really, really important to improving the adoption of static analysis kinds of tools, especially in the cybersecurity where we have so many vulnerabilities that need to be accounted for. So the classification scheme, I imagine, is a big part of this in terms of how do we make these false positives more visible or less visible, I guess, depending on how you look at it, but making it clear which ones are the false positives from the true issues. You want to tell us a little bit about sort of how that plays out, Zach?
Sure, yeah. So making a classifier for which alerts are most likely to be true positives depends on a couple things. One is you have to have a good set of features on the input data, on the alerts, descriptors of each alert that you could feed into a classifier to decide. And the other is you have to have a good classification framework. And we've so far tested a few different classifiers, and the one that seems to work the best for now is a gradient boosting machines implementation. I'm using Microsoft's open source LightGBM at the moment, but there's others that would work comparably. I think for big improvements in accuracy, it's not so much the choice of classifier, but improving the feature set in the future.
Okay. So what is the impact of that scheme that you're using on how programmers actually do their work? Do they need to change the way they do their work to improve the feature set going in, or is it we take all comers, in terms of how we deal with this, and we use the classification scheme to work through what we're being given? How is that playing out?
Well, this should have no effect on how programmers work.
They'll be very glad to hear that.
Good.
I mean, that's a big deal, because a lot of times we come up with these new technologies and the first thing we say is, and now you have to do this in addition to whatever else you were doing. So if they can use these tools without actually having to change the way that they would normally do their code analysis, the coding and the analysis of it, then
I see.
That's a good thing.
So the one piece of overhead is that they would need to create the feature sets that the classifier needs,
Okay.
which means running some analyzers that develop features based on any input code set. It wouldn't. I don't know if they would have to be. The system we've developed should eventually get to the point where it can take any features they have available to feed
Okay.
the classifier.
So there's a little bit of work to do, but that's also automated for the most part.
There are metrics tools that automatically compute features for code bases.
Good. Okay.
Any other features they could add could be as beneficial as well.
Good.
Yeah, so there are many different static analysis tools that can be used. There are many different code metrics tools that can be used. Right now, we're using those two types of tools to develop features. In the future, we plan to use other types of tools that have been shown in other people's published research to improve classifier accuracy. So
Okay.
there are dynamic analysis tools and some graph analysis tools that have also been shown to be helpful in increasing classifier accuracy.
So you're working on both of those, both fronts, the classifier accuracy and the performance of the analyzer itself, in terms of being able to automate in a way that gives information that's relevant to the coder, right? Not just to the metrics tool itself.
So let's see. Now is a good time to talk about the evolution of this project. So in the first year of this project, the focus was trying to create classifiers using output from multiple static analysis tools. And using the names of the static analysis tools that provided alerts for a particular flaw as features, we explored whether that would improve the accuracy of the classifiers, and we found that it did. And that was not surprising, because other research has shown that static analysis flaw finding tools tend to have a somewhat overlapping set of flaws that they find,
Sure.
but there's, looking at the Venn diagram, there are usually a lot of flaws that are not in the overlap. And so by using the results of multiple static analysis tools, we're both able to identify more flaws, and sometimes, having information about particular combinations of tools providing alerts helped us to create more accurate classifiers.
So what are some of the challenges of doing this kind of work, trying to improve the classifiers, trying to find the data that would be useful in expanding the predictability of the classifier framework? What are some of the things you've run into?
Sure. So one of the key challenges we're working on is how to best use test suite data, which is on essentially fake synthetic code, to use that synthetic data to pre-train a classifier so that it becomes more accurate on real data on any new application.
Okay.
And this is largely experimental, but it's a field. The field is called transfer learning, where you take data from one domain and try to use it to predict data in another domain. And there's not always a solution, but we can try it works best when the features in the training data set are similar to the features in the test data set.
Sure.
So if you're measuring things like the number of lines of code in a file, not that that's an actual feature we'd use, but just for an example, maybe the training data set, the lines of code just range from 1 to 100 typically for some reason, and then in the test data, or in the target domain where you actually want to apply this in a user's code base, maybe the range of lines is more like 100 to 10,000.
Sure.
I don't know what's a reasonable number. But obviously those numbers in the training set are not really comparable to the
Yeah.
ones in the test
They're not
set.
at the right scale.
Right. So a very simple transfer learning technique is to rescale the target domain variables to be on a similar scale. So maybe you look, you just divide everything in the target domain so that they're ranging from 1 to 100,
Right.
just like they are in the training set. So you could do that kind of thing. There's much more technical transformations out there which are kind of reminiscent of principal component analysis. Transfer component analysis is one thing that's been published. So you just transform the target domain data to look more like the training data domain, and then
Gotcha.
it might work better. Now, I've just started to look at that. We haven't really integrated that yet. There's some other techniques, like when you begin a new project in a company that wants to use this. At first, they won't have any data, and so they might want to use the test suite data
Right.
to train the classifier. But over time, they gradually acquire more and more in-house labeled data. And so as they get more of that, the test suite data will become less relevant.
Sure,
So how
sure.
do you manage the trade-off between using the test suite data and the new data as the ratio of data availability switches? If you have just one new data point and lots of test data, well, you still need to give a lot of
Right,
weight to the
right.
test suite data. But there's an optimal way to balance which data set gets used more until eventually it's basically just using the in-house data.
Right. So that's almost its own research path in terms of figuring out what the balance is, but what's the point at which you want to turn off test suite data.
Right.
And so you're going to be busy for a while.
Yes.
So what's the most non-intuitive thing that you've discovered as part of this work? I mean, as you talked about, we expected that we would see, some overlap in the tools and things like that. But what was a surprise in terms of what you've done so far?
So that was actually, it was a novel result. So there's a lot of published research on single static analysis
okay.
tools. But there were only, I think, 3 papers I could find on Google Scholar that used more than one static analysis tool, and none combined sophisticated classification algorithms that, in the way we did. So that was a novel result, even though we were suspecting
Right.
that we would get the results we did. Then last year, we worked on using static analysis, or using test suites like Juliet and Stone Soup,
Okay.
test suites that are intended to test static analysis tools to see which flaws they find, and there are flaw taxonomies like common weakness enumeration, CWEs, and there are many aspects of a particular named flaw.
Right.
So these tools find, they really test the tool. These test suites test the tools to find, combinations of control flow and data flow and type flow, and to figure out which tools get stumped
Right.
with complicated combinations of those, and which are still able to find flaws, and which tools never find the flaws, even in really simple cases. So the novel thing last year was using the test suites to generate our alerts. The reason that we did that is because in the first year of the project, we ran into this problem with the classifiers being very bad at classifying alerts for flaws that they had no data for.
Okay.
So we have a set of audit archive data that where CERT people have manually audited alerts for code bases, and
Right.
experts have determined whether the warnings from the tools are true or false positives.
Okay.
So we have this big alert audit, alert audit archive, and we use that to create classifiers that first year. But for flaws that we don't have audited data for, our classifiers were very bad,
Right.
which is not
Sure.
surprising
Not at all.
also. But it's very expensive to have auditors audit for every alert. You have to have trues and falses to create classifiers. So the idea with using the test suites was to see if we could, by generating labeled data, by automatically generating labeled data, true or false, for alerts, using the test suites, can we create accurate classifiers for all kinds of flaws that we don't have manual
Right,
data
right.
for. So the test suites come along with some metadata that says, on this line of this file, there is this exact flaw,
Right.
CWE 190. So we created some scripts that just parse through the static analysis output and label the alerts. And this would probably be a good time for Zach to talk about some of the classifier accuracy results from that work.
Sure. I don't have all the numbers right off my head, but the classifiers that we trained on the test suite data, these artificial alerts with labels, were pretty accurate when they were predicting on other artificial alerts,
Okay.
which is not too surprising. We got, I don't know, area under the receiver operating characteristic curve of something like 0.98, or it was good. But the challenge then was, does that generalize out of that data set
Sure.
to a new data set? And it did not generalize very strongly. I think there's some signal there, but it's a bit weak in our initial results. So we're still working
That means
on
you get more research.
Yes.
Do you have any insights yet as to why that may be an issue?
Well, there's the test suites are constructed very artificially, but with some realism.
And they're focused on a subset of
Yeah.
the possible vulnerabilities, right?
Right. So like a typical test suite file might be much shorter or cleaner than a typical real world code file. I'm not sure what all the differences are. And it might focus on one particular vulnerability instead of a mixture of
Right.
them. So the structure of the test suites is considerably different than code in the wild. And yet there could be some similarities, so we're still digging there.
So I imagine there's a lot more noise in the code in the wild is part of what you're probably dealing with.
There's more noise and different kinds of noise.
Yeah. And figuring out how to get the classifiers to recognize the noise versus things that we really need to pay attention to is the challenge.
Right.
Yep. It's all about noise.
Exactly. And in last year's work, we were using the Juliet test suite, the Juliet C and C++ test suite, which has small programs, very small programs,
okay.
about 1 to 3, short files long. So they're not very typical. This year, we're starting to add to our data set with Stone Soup data. The Stone Soup test suite uses real open source code bases. By real,
okay.
I mean naturally developed
Right.
code bases. For instance, like a version of Eclipse
Sure.
that are then artificially injected with flaws. So they're much larger and they're naturally developed except for the artificial stuff at the end. So we have yet to see the effect of that data on the classifiers, so that will be interesting. Another thing that we're trying, that Zach is trying, is to use cross-project classification techniques. So there are techniques that have been used by others and developed by others for developing labeled data in one type of project and using that data effectively to augment, to enhance production of classifiers for another set of data. So that's a big focus of Zach's work this year.
So you've been playing around, working with a bunch of different sort of open source, publicly available kinds of things. Have you been testing this? Have you got any organizations that you can talk about that you've actually piloted this with in terms of actual coders trying to use this to improve the security stance of the code that they're producing?
Yes, there are 4 organizations who we can't name, I'm sorry, but there are 4 organizations who are collaborators with us, and 3 have previously provided us with a sanitized version of their data.
Sure.
We gave them a sanitizer, and we gave them a tool that their auditors used to mark static analysis alerts true or false. And that tool that we produced, it's called Scale. That tool exports data into a database, and we provided a script that sanitizes that database, where it removes all messages, that kind of code snippets, and for every place in the database where a file name or a directory name or a function
Something
name is
identifiable.
mentioned. Yeah, we do a SHA-256 hash with a salt that they create and they keep. So that the version of the database they gave us was sanitized. Nothing
clear,
sensitive was there, but we still were able to create classifiers, create and apply classifiers using that data, because for some uses of features, you want to know if the function name is the same, or you want to know certain things about a depth of a file. So that data was still available in the sanitized databases.
So you're getting out into the real world with this, so that's good. What are your plans, if any, for allowing maybe some open source customers, some other folks that would like to understand how to use this in their work? What kind of plans do you have for making something like this available to them? And would they need to work with you directly to create things, or is there going to be sort of a self-service kind of way of working with the tools as they become available?
So there is a version of Scale coming out of our project. Let's see. Scale is a tool that's a framework for static analysis alert auditing that has a front-end GUI that allows views of static analysis alerts and of code, and has a back end that exports to a database, like I said. So the secure coding team has been developing that tool for a total of about 9 years. And for the last 2.5 years, my project we've done the development of that tool. And it's always been closed source during all of the time. It's been developed by the secure coding team, but that's about to change. A February version of our project's Scale prototype is about to get published on GitHub sometime soon. So we're doing some other exciting things with Scale and with classifier development, and actually we're building an architecture that will enable many types of systems like DHS Swamp or Scale or Army CertX Swamp, many different types of systems that that provide this auditing framework. We'll be able to plug into our architecture, and with certain API calls, we'll be able to create classifiers and create sophisticated alert prioritization schemes. If
So
they
they can
want
create their
using
own
the
triage
results of
scheme,
classifiers,
essentially.
exactly, sophisticated triage scheme, and our intent is to eventually put all of that on GitHub. We don't. It'll
You don't
take some
control
permissions.
all of those, yeah.
So I can't say when that will happen or if for sure, but
Getting one version out is significant to the people that are trying to prevent vulnerabilities from occurring in their world. So I think that there will be several of our listeners that are going to be interested in what these tools can do for them. So beyond the blog posts and the other things, can people get in touch with you? Are you open to new projects to work with on pilots with this technology? So that seems like that would be a place if people think that they may have a fit or they may have a need for the kind of triage. I know a lot of coders that I know would like, please triage my code so that I don't have to look at all these hundreds of alerts. So I think this is very exciting in terms of the usability of this kind of technology, because that's been the big issue, all these years, is nobody wants to look at the reams and reams of alert data to figure out which ones are real.
absolutely. And although people have been working on alert classifiers for a while now, and there are some really great methods, it's right now it takes a stats expert
It takes
or a team of them to set that up.
Yeah.
And it really helps if you have a huge data set. Like Google does work with Google uses classifiers with find bugs, and they have super high accuracy rates doing that, but they also have a really enormous, wonderful database.
Yep.
So we're hoping that using this test suite trick to generate labeled data and creating this architecture that just regular folks can plug their tools into, that we can help them out.
No, I think that's I think that's very hopeful for the folks that are trying to use these kinds of tools to actually triage what's going on. And I look at a lot of the work I do. We work with development test, operational test, certification authorities, and they're always looking for ways to compress the time that it takes to actually be able to say, yes, this is, you've done the due diligence on this and have eliminated as many vulnerabilities as is reasonable based on what we know. And so these kinds of tools can be really critical to that whole process of compression. So that's very exciting. I want to thank both of you for joining us today, and I hope that our listeners and our viewers will be able to have some interesting times working with the tools as they come out, and that they will also read and look at some of the other work that you've done in relating to this. Some stats experts out there may want to get in on some of the details of where some of this has been going. So we will be providing links to all of the transcripts here, but also to links to GitHub when that becomes available, as well as to the blog posts and other things that are related to this work. So there'll be plenty of resources for people to look at in relationship to this. So I hope that'll be helpful to your project. So I want to make sure people know that there is a blog post, I've mentioned it, that Lori and Zach have authored on this. And the easiest way to find that is to go to our blog area and search on Lori's last name, Flynn, Flynn, and the things that are related to this should come up. So that will be a useful way for you to find new things. This podcast will be available on the SEI website, www.sei.cmu.edu/podcast. Also on Carnegie Mellon University's iTunes site and the SEI's YouTube channel. We have one. So thank you for listening, thank you for viewing, and thank you for joining us today.
Thank you.
Thank you.